building a solid math foundation. If that's what you're looking for, you're in the right place. I'm going to spend about 20 minutes talking to you, going through most of my PowerPoint. I might skip through some things fairly quickly. And then I'm going to give you about 10 minutes for questions. Of course, you can feel free to put some questions in the chat or raise your hand as we go, and I will do my best to call on you. But often if it's in the chat, I can't quite get to it, but if I can check it when I spend that last 10 minutes. So with that being said, let's start talking about building a solid math foundation. Okay, I like to think of math as like a house, right? If you put on your bottom layer, kind of that the whole foundation is going to be number sense, and then we have place value, and then visualization and strategies. With all of these things into play, you're going to get a solid understanding of math. Okay, so I'm going to go through what I mean by those throughout this presentation. Okay, a lot of times though, we think of counting, right? Oh, my child can count to 10, my child can count to 100. Like, isn't that swell? But that doesn't really do much, right? Or we hear, when should they have their multiplication facts memorized? A question I see a lot on our chat boards is, my child doesn't know their multiplication facts. What else do you use? What can I do? We're not looking for memorization. We need understanding, because memorization can fail us, okay? Same with procedures. If you just say, do it this way, when you come to a problem that you can't quite make work that way, all of a sudden you have a problem. And then when we don't put enough, we just kind of maybe throw place value in the house, but we don't give it a sturdy bearing. We don't have great understanding, and it all starts to fall apart. So number sense, place value, strategies, and visualization, all of those together are going to give you your house, your solid foundation. So looking at number sense first, okay? I like to think of number sense as the phonics of math, okay? It's the ability to not only recognize the number, but to know its value. And we place a lot of value on counting. Counting can only take you so far. Counting is the naming of something, right? Letters are the naming of something. But if we don't know the sound that the letters make, we can't read a book. And I use reading as an example because people are very quick to say, I'm not great at math, but there's a lot of shame, unfortunately, in I'm not great at reading, right? So we have this strong importance and value on reading, but how can we play it into math? Well, how do those come together? Okay, so we want to be able to know what the letter sound is for the letter, just like we want to know what the value or of the number is. Okay, so one way that we do this is subitizing. Subitizing is just a quick recognition of quantities without counting. If I put up this hand, I'm pretty sure all of us can say 3. We don't need to count 1, 2, 3. Believe it or not, small children can do this. Babies can do this, right? If you've ever had, maybe they're playing with something they're not supposed to, right? And you take it away and you hide it. They still know it exists, right? You could have 2 teddy bears. This is an example, I believe, in level A. 2 teddy bears, you take one and hide it. That little toddler or baby is still going to know that there should be another one there. They know the quantity. They can do that on their own. So we know that children who can subitize perform better in math. That's a fact. Subitizing allows children to grasp the whole and the elements at the same time. Okay, and then subitizing seems to be a necessary skill for the understanding when the counting process, for understanding what the counting process means. Yeah, we have to count things sometimes, but what do they mean? What does that counting mean? What is the value of that? I just want to take a quick check. Am I going too fast? If anyone needs me to slow down, let me know, because sometimes I get talking fast. I live on the West Coast, but I'm from Boston, so I can get going quick. All right, so subitizing again, right? So we have our 3. We can see that. You know that this is 3. We can see 5 pretty easily. And we have like we do tally marks, right? Anyone that's ever done tally marks, right? You do 4 and then the line across is 5. We can tell right away that's 5 because we have little systems. We like groupings of 5, just like our abacus is set up. If you've ever seen our abacus, it's in groupings of 5. It's actually the profile picture from Martin, right? That's what our abacus looks like. Okay, then you can talk about comparing numbers, comparing 5 with 4. Okay, You go one in, 5 has a middle. That's different. 4 does not. Okay, that's something that the child can quickly see if you use some sort of manipulative. Okay, so you can start on the outside and move, and you see, oh, there's a middle. That's 5, not 4, right? That's also a way you can tell odd and even numbers per child. So again, if you were to look at that, I'm confident that you guys would tell me 5. This one, we're seeing like the tally marks. So this is a grouping of 5 and 2. Just like on our abacus, this is 5 and then 2. You see the color change, right? You can look here and know that that's 3, right? So I have just shown you on the abacus. I'm gonna just kind of click through these, but you would say if you're working with your child and you're trying to get them to understand the number sense, right? In the subitizing, right? You might say, okay, 3, show me that on the abacus. And then they're going to show over the 3 beads. You don't want them to go 1, 2, 3. You want them to be able to do all 3. Again, 5, they should be able to quickly be able to figure that out. 7 is 5 and 2. And then 10 would be all the beads. Okay. So I'm gonna go a little bit off. So today I also answer phones as one of my jobs at RightStart. Today I had a caller call in, and she was struggling with her daughter's can't name the numbers like between 4 and 8. And she was really struggling with that. She's like, how can I fix this? How can I fix this? And I was like, let's worry less about the naming of the numbers and more, it went very nicely to the subitizing. So I gave her that exact strategy that I just showed you, right? Where you show the number with the hand and then have them do it on the abacus. So they're seeing that played out. And then always games, right? So we think of games to math would be comparison to books and reading, right? You could do phonics all day long, right? But once you get that book in your hand, things get exciting. You go off on adventures, you learn new things. Games are the same way. Games are providing us that interesting repetition needed for the automatic responses. So you don't need the memorization. You just need the repetition. You need the practice. And then all of a sudden you have it. Okay. They provide an application for the new information. You're learning all this stuff. Well, what can I do with it? Well, where can it go? Right. You could use it by applying it in games. Not just our RightStart games, but all games. Okay. People enjoy playing games. It's a good social activity. And having a good understanding of math will help you with that and all sorts of other things. You have your problem solving and strategy and all that. But yeah, games are your application. That's where you get to put into practice what you're doing. Okay. A quick, easy way that you could do it is you could have them take the bead cards and you're going to have them put them in order, right? You're seeing those different things. You have them mixed up, but they have to find the quantity. Okay, so that's just looking and knowing, okay, that's 1, 2, seeing the groupings and knowing where the things go. Okay. Counting. We can look and say there are 4, but when we count, we say 1, 2, 3, 4. Okay, sure, we understand that quantity is 4, but the child oftentimes understands it as a naming, right? Well, this one's 1, this one's 2. And this is 3 and that's 4, but not that all of them together are 4, which seems silly, but it's the real thing that happens, especially when your kids are struggling with place value. That's how you're going to know. Okay. So if you think about if you're adding by counting, so if you say, you have 2 and then you add 4, your child's going to count up 1, 2. Okay. And then 1, 2, 3, 4, and then they have to kind of start all over again, right? So kind of a way to make you see this is I use the alphabet. So if we assign every letter with a number or every number with a letter, you could think of it as F plus E. Does anyone feel confident that they could quickly answer F plus E? Probably not, right? So if we think about it like this, so we have A, B, C, D, E, F. Okay, that's my F. Now A, B, C, D, E. Okay, well that didn't get me very far, right? Because I still am not sure what F plus E is. So then I have to start at the beginning, A, B, C, D, E, F, G, H, I, J, K, right? Oh, the answer is K. That's a lot of work to get from 6 plus 5, okay? 6 plus 5 is 11. If we know that this grouping is 6, and not 1, 2, 3, 4, 5, 6 or A, B, C, D, E, F, we can get to where we're trying to go a little bit faster. Okay. And then just is right. You give it to them the same way. Okay, I want you to learn to count. Now I want you to memorize these facts. It seems nearly impossible. All right. So that's the start on our number sense. Now let's talk about place value. Place value is extremely important. That's undermining it. But I know my math education, I don't think they placed a lot of value on place value, a lot of stress on it. And I still had trouble with things like million. I had to stop and think about it. And I was someone that was in honors math, that did college math. And so, you know, doing place value with my own kids through RightStart has really improved my math and my understanding. So as a kid, if L is written AB because it's AJ and BA's, what am I actually trying to say? What does that mean? Okay, so L is 12. AB would be 1, 2, because 1J, AJ is 110, and BA's is 2 ones. That's pretty confusing, right? So children often think of 14 as 14 ones, not 10 and 4 ones. Okay, the pattern needed to make sense of 10s and 1s was hidden in the English language. There's so many other languages that play nicely with the numbers, right? But here we change a little bit. So with RightStart, we show the transparent place value. All right, we talk about numbers a little bit different so that you can help see the place value, and then your child can and will transition easily to the math name of saying things. Okay, so here's our abacus again. We have 110. Well, we have 10, then we slide another over, and it's 210. All right, this would be 210 4. Because you have 2 10s and then 4 more. Okay, and then 210 8. Okay, 210 8, and then I have some more examples: 310 310 6. So what does all this mean? The transparent number naming: 10 obviously equals 10, 11 is 10 1, 12 is 10 2, 13 10 3, and so on. And then you get to 20 and you're like 20 210, 210 1, and so on. Okay, why do we use this? I already talked about it a little bit, but patterning, right? You have 3,000,000, 3,000, 300, 310, right? 310 stays with the pattern more than 30, and you can see where that comes from. Place value, it helps us see the actual value, where it belongs in the process. So 310, so we might build this, we might say, okay, show me 310. They're going to put it on the abacus, and then you're going to have them maybe find a place value card. So you're layering it. You're getting some of that practice, some of that repetition. Okay, so 310. Okay, then you'll say, okay, 310 7. So now they have the 310, but then they have to find the ones that are 7, and they place that on top of in the ones place, and it gives you 37 or 310 7. Okay, we have 10 10s, which give us 100. Okay, so transparent number naming just helps us see the patterns. It helps us make those connections. So again, 310, 300, 3,000. Okay, and then the kids could build. And so this was one thing. My daughter is now in 7th grade. She's an H. But I remember her struggling with some of this. I want to say it was in level C or D. She was having trouble making the trades. So I remember at the library, I gave her place value card. I had her build it. Then I had her build it with the, oh my gosh, the like base 10 card where it has like the 1, the 10, the hundreds, all that. And she had to build it and put them in rows and add them together. And then she would trade them with me like the bank. And that gave her the confidence to see where it all goes together. Okay, so she put down 3,000, 600s, 5 10s, and 8 1s. And then she was able to see, okay, that makes this whole number. Then when I'm adding another 4-digit number, I can see, okay, all my 10s go together. Oh, I have 10 10s. I'm going to trade those into you and get a 10. right? I mean, I have 10 ones, I'm gonna trade that in and get a 10. So you can really build with this stuff, okay? So again, back to the language stuff, the reading. Just as reciting the alphabet doesn't teach reading, counting doesn't teach arithmetic. We first teach the sound of letters, then we first teach the name of the quantity, the math way. So some countries, this is how they teach math, using the math way of naming numbers. That's just how they start. There's been some, Dr. Cotter found some research that said understanding of place value in first grade, only half of US students understand place value by the end of fourth grade. So by the time you get to fourth grade, if you don't know place value, you're kind of in the dust because no one's coming back to figure it out for you. Okay, where in other countries they have it figured out by first grade, only about half of our US students have it by the end of fourth grade. Okay, so math is the science of patterns. The pattern math way of number naming greatly helps children learn number sense. Okay. So after we did the transparent ways, you then go back to the traditional ways of naming numbers. So 410, why is it this way? 10t, right, is 4t. So 10 equals t, so 40. Okay, so we're gonna play a word game. So fireplace, and then we're gonna reverse the order. It's gonna become place fire. Newspaper would become paper news. Box mail would become mailbox. Now, why am I playing this? It's to show you how our teens work, right? 10, 4, 10 equals teen. Then you have teen 4. When we play our game and flip it, we have 14. Okay, so we do the same thing with 10, 8. Teen 8, 18. Okay. Okay, how does 11 work, right? It's a 1 left, or a left 1, which then becomes 11. Same thing with 12, 2 left, 12. Okay. Next, we're going to talk about visualization. Okay. Visualization is to form a mental image or a vision to imagine. It's important for critical thinking. You use it in everything: math, science, sports, chemistry, surgery, how to give someone direction somewhere, right? You're visualizing the turns and the landmarks. We intuitively use that all the time. So let's show our kids how to use that in math, okay? Strategies are a way to learn a new fact or recall a forgotten fact. A visual presentation is a powerful strategy. The abacus can provide a model for visual representation. Your child can start visualizing the abacus, the groupings of 5s, then they can start using that for different strategies, okay? So the abacus is a visual and tactile manipulative, and it promotes subitizing, sorry. It develops a mental image of quantities, strategies, and mathematical operations. And I'm going to show you a couple of these strategies on the slide here. So if you have 4 plus 3 with your abacus, your child's gonna push over 4 beads, and then 3, not quite all the way over, because I have 4 and 3, and then they push it together and they see, oh, that's 5 and 2, that's 7, right? They can start to make this mental picture. Same thing with 9 and 5, right? You could do it with the 10 strategies, right? You could put 9 on your top bead, 5 on your second, 9 on your top wire, couldn't think of the word, and 5 on your second wire. If you want to complete 10, you're going to take that yellow on the top, you're going to slide it over, and then you push one of your blue ones over. And it's a lot easier to see that 10 and 4 is 14, 9 and 5 is 14. Okay. 2-5 strategy, doing the same thing. Your top wire is going to be your first number, it's going to be your 8. Your second wire is going to be your 6, your second number. You can see that there are 2 groups of 5 here, and then you have your remaining yellow ones, which is going to give you 4. 10 and 4 is 14. 8 plus 6 is 14. So it just gives a visual way, another way to do it. So again, showing the 2 5s. You have your 10 and then 2 more, which is going to give you 12. You can also do this with subtraction, 15 and 9. So you have your 15 here, and then you're going to subtract 5, because that's easy to do, to slide all these over. And then if I subtract 4 more, I'm left with what we have, which is 6. Okay. So when you're working with your child, you can give them all these different strategies. I know for my kids, they have different preferences for what subtraction strategy they use. Okay, and I have a different preference, but having all 3 gives us the ability that maybe someday, like the all from 10 strategy is just not clicking. So you don't use it, but you might use your going up strategy. And I'm running low on my talking time here. So 15 minus 9, you're going to subtract all from 10. So if you took 9 away from this top one, it's going to leave you your 6. That's the all from 10 strategy. I'm going to show you going up. This is the one my daughter loves, and it makes my head want to hurt. But we have going up. So you start with your 9, and you have to get to 15. So you put 1 more over 10, and then 5 is going to tell you that it's a difference of 6. Okay, let me see. And then you also have on the second side of Abacus, we have our thousands, our hundreds, our tens, and our ones, which is going to help us with our visualization. This is kind of what I do with the base 10 cards as well. You see you have 10, you have to make a trade and leave 4. Okay, I'm going to click through this. So Abacus is a physical needed to develop mental image, real imagery to mental. If a child is struggling on counting, use the Abacus. It is a tool. It is not cheating. It is a tool. Okay. So all of those things together are going to give you your solid understanding. So just as reading is much more than decoding phonics and word attack skills, mathematics is much more than memorizing fact and learning algorithms. Just as the goal of learning to read is reading to learn, and for enjoyment, the goal of math is solving problems and exploring wonder. Bonding to everyone. It's just one of those things in life that makes you feel satisfied to know. I believe that this is part of a chat from one of our classes, but I could be wrong, from one of our students. Okay, so now I open it up to you. I went a little bit over there, but I'm here to take any questions that you may have or comments. Are any of you current RightStart users? You can give me a thumbs up or even put it in the chat if you want. Nobody? Okay. Yes, okay, Emily is, Yen is, I hope I said that right. I'm sorry if I didn't. Rip the chart of the solid foundations again. Yes, I can. I forgot some codes for you, but I think that's okay. Is this the chart you're looking for right here? Okay. Okay, Sherry just started. Yeah, so just personal anecdotes, since I don't have any questions. So I have 2 kids. My youngest started in kindergarten in A, and she's in H right now. She's doing very well with it. My son had been in public school, so he didn't start to C, and he finished all the way through H, and now he's doing art of problem solving math. So it works, and they have progress there. So I understand conceptually it's more important than memorizing facts. But does there come a point where you take away the multiplication table? No, we don't take away the multiplication table or the abacus ever, because they're tools. Eventually it will disappear. It feels like it won't, but with the more practice and the repetition, it will eventually go away on its own. Okay. Maren, where can they get the recordings to hear the first part?
Those links will be emailed out to the group as they signed up for it.
Okay, perfect.
We'll try to have them out by the end of the day.
Okay. Yeah, and I know, even the RightStart lady, my kid the other day pulled well, when am I ever going to use this stuff in real life? And my husband's a lawyer, and he's like, you use math all the time in real life. It is critical thinking. As a lawyer, I need to, he's an army lawyer, so he's not billing anybody, right? There's always that joke, but he needs to use those critical thinking steps on, okay, I have to isolate this to get it over here. How can I fix that? So giving your kids that solid foundation of math is just going to set them up for success in whatever it is they end up doing. I think all these come into play, visualization strategies, you're using that for everything that you're doing. So I'm willing to take any more questions if people have them. I don't want to just take your time with anecdotes here, but if you don't have them, that's okay too. Knowing them automatic, like memorization, or just like, well, let me see. Yes, you should have an understanding of your math facts. It's more about being able to understand how to get them and how to play them. Memorization is not what we're looking for, because that's quickly going to go that's going to kind of fall apart on you. I mean, I remember as a kid, my parents just drilling me with the flashcards for memorization. But we kind of got away with that, because when you're doing all these other things, when you're understanding how they play together, you don't need the memorization in that same sense. Eventually it comes. I feel like I'm kind of talking in circles. I hope this makes sense. For memorization, for the memorization's sake, not important. It can almost be detrimental if you're just kind of drilling them for it. But memorization, and the fact that I've done all that application with the games and with the abacus and everything else is wonderful, right? Because once you do all those layers, or if you have, go back to the multiplication chart, right? If you have that visualization of the multiplication chart, you're essentially are kind of memorizing it, right? But in a different way, you're visualizing it. It's just like, how do you get to the grocery store? Well, I go down 3 rows and I go over 5, and that's 15, right? That's how I get to the grocery store. Does that answer your question, Tara? Yes, that's exactly what I'm trying to say. That is a shorter answer. Yes, through application and just understanding, they're going to memorize them. I mean, I remember my husband helped my daughter in like D, and he's like, she doesn't know her multiplication. Because it wasn't automatic. Like, it wasn't like how we learned it, as both of us had gone to public school, but she knew it. She's fine. She's an H now, she's doing fantastic. But it looks differently. It looks different than, just being able to spit out the answer, because you might be able to spit out the answer, but what does it mean? So that's kind of what we're doing. And yes, it'll also develop their problem solving skills to figure out how to get there. My kids definitely do some things for math. I'm like, how did that happen? Okay. I can see the frustration for that. Is she, I think you said she, is your child able to, yeah, she, able to like do it on other things? Do you think it's a confidence thing, or do you think it's a not knowing? Because I know, like, I have one that's a perfectionist, and I think there's that fear of getting things wrong. That can sometimes hold them back. Okay. Maybe, I don't know, maybe you could say, and I know it's another tool and it might not quite be the same, but maybe have her do the multiplication like on the abacus, right? Okay, today, say let's just try it without the multiplication table, but you can use the abacus, right? So I don't know why I keep using 3 and 5, but okay, 3 and 5, we're gonna do 3 of 5. Okay, you see that? Or you can do 5, 3. You see all those 5s, that's 15. Because if it is a confidence thing, it's just something that she's gonna have to, work through, unfortunately. But if you're playing the games and you're doing the other stuff, it should come along. If there's no other like learning challenges or anything like that. We don't have any hard and fast age or grade. And that's a tough question. I think you'll be surprised that just having the strategies and the place value, even if it's not memorized, is just so powerful that it's going to get them there quickly, right? Okay, so you might not have your 12s memorized, but you have your 10 facts and your 2s memorized, so I can quickly get there. Why do I have to memorize my 12s or my 13s if I know these other ones I can get there quickly? So as far as just like memorizing and being able to regurgitate it, no actual age for that, but the visualization and strategies are going to make them successful in that way and quickly with that repetition. Anything else? And does that answer your question? It is. I mean, I've been in the same struggle with the facts. My oldest is dyslexic and has significant ADHD. And he, like I said, he finished through RightStart, started C, went through H, and he's now in Art of Problem Solving, which is a very challenging curriculum. I let him pick, and he's actually doing really well. And he's one of the ones that if you ask him for his facts, he's not gonna be able to simply spit it right back out, but he's doing extremely well in this other program. So, you know, he's not using calculator, he has crazy mental math because he has that visualization piece and the strategies. So trust the process, which is really hard. It's our kids' education. We want to make sure we're doing it right. But you're here, so you're in the right place, and just trust that you can get them there and they'll get themselves there. You can do it. Well, if no one has any other questions or comments, then I guess we're good. Have a great day. I know there are some. I know Miss Debbie is speaking later today. I think maybe a half hour. I'm not sure, about older kids in RightStart. She's a fantastic resource. Lots of good talks going on the next few days. Thank you all for joining.